भावों का समागम।
जयति जय जय जयति जय जय ज्ञान का आलोक अनुपम।
भव्य महाविद्यालयों के परिसरों से चिर सुशोभित श्रेष्ठ गुरुजन कर रहे नित्य छात्र और छात्राएं दीक्षित।
पावन साधना संकल्प संयम।
नवल वैश्विक चेतना नव क्रांति संस्कारों का उद्गम। जयति जय जय जयति जय जय ज्ञान का आलोक अनुपम।
विश्वविद्यालय विहंगम।
जयति जय जय जयति जय जय ज्ञान का आलोक अनुपम।
ज्ञान का आलोक अनुपम।
ज्ञान का आलोक अनुपम।
ज्ञान का आलोक अनुपम।
Thank you, everyone. With this positivity, I would like to start today's event. Now, I would invite Professor Kamal Kumar Gupta, sir, to welcome and felicitate our eminent speaker, Dr. Veera Noth Nisha Patron, by presenting memento and bouquet. Welcome, ma'am. Thank you, sir. I would invite Professor Sunil Kai, sir, to welcome and felicitate Dr. Ashish Avasti, sir. Thank you, sir. I would request Professor Indrakant Kumar Singh, sir, to welcome and felicitate Professor Kamal Kumar Gupta, sir. Thank you, sir. Now, again, I would request Professor Sunil Kai, sir, to welcome and felicitate Dr. Aditya Saxena, sir. Okay. I would request Professor Varsha Baveja, ma'am, to welcome and felicitate Dr. Aditya Saxena. Thank you, ma'am. Now, I am hand over mic to my fellow host, Dr. Jaya Malhotra.
Thank you, Dr. Sushma. I request Professor Kamal Kumar Gupta, our senior most faculty at Department of Zoology and also a former principal Deshbandhu College, to come and share a few words of wisdom. Please, sir.
Yeah. Good morning. And it's an honor for me to be here in the International Symposium on Advances in Health Science. On this occasion, I take an opportunity to welcome our keynote speaker, Dr. Veera Noth, Dr. Ashish Avasti, our IQC coordinator, Dr. Aditya Saxena, the faculty members of Zoology Department, Professor Sunil Kayast, teacher in charge, Professor Indrakant Kumar Singh, our senior faculty members, Professor Varsha, Professor Manisha, Dr. Rocky, Moses, all the faculty members from zoology department, teachers from other departments of Deshbandhu College, teachers from other colleges, delegates, welcome to you all on this occasion of International Symposium. This symposium was visualized by our respected Prime Minister vision that Viksit Bharat at the rate 2047, that we want to see the status of our country from developing to developed within 100 years of independence. And target is not far. We are already progressing on this. So when we go for a Viksit Bharat, health is very, very important. And that's why we say Viksit Bharat, Swasth Bharat. Swasth, health. Here we'll be discussing the what you call health, advances in health. I think our age-old tradition, my grandparents, maybe more than 100 years, they used to say, Pehla Sukh Nirogi Kaya. Means the very first thing is that we should have a good health. Then you must have come across a saying, what we say, a healthy mind lives in healthy body. So what I say, what health means is that healthy body is health. Probably I have to explore it further. I have to extend it further. Health is not just physical health. Mind should also be healthy. So I can say that well-being of society can be achieved by physical health, mental health. But if our mind is healthy, our body is healthy, does it suffice? Probably not. We have to go beyond that. And for that, I say healthy society. So UNO define health as physical, mental, and social well-being. But as a person, I'm not satisfied with these three words. I want to include much more than that. And what I say, spiritual health also. If we are spiritually healthy, our body is going to be healthy, our mind is going to be healthy, and society will also be healthy. Though UN has not added this word, spiritual health, but I always wish to have the spiritual health also. I'm thankful to all the delegates here who have come and attending this, but trust me, it is going to be a wonderful interaction, wonderful session. And at this juncture of play time, I also want to thank our principal, Professor Rajendra Kumar Pandey, who always supported wholeheartedly zoology department in hosting this event. Our guest, Professor Ramesh Goel. Of course, he couldn't come, but he always support us in hosting the events. And Professor Sunit, who will be coming in the valedictory session. So, and one more guest who will be joining us after lunch, Dr. Roshan. So this, three keynote speakers are there and also one valedictory. So in a short span of one day, we are including diverse topics, diverse fields, and that's going to give you a holistic vision about the health and how we are going, what are the challenges and all these things. I also want to appreciate the efforts of zoology department, my own department, and in that way, the efforts of Professor Sunil, Professor Indrakant, and the organizers, Dr. Sandhya Rai and Mr. Mohammed Shahzad is really praiseworthy. Thank you, and have a wonderful time and a very successful symposium. Thank you.
Thank you so much, sir. You have very well elaborated the aim of Viksit Bharat to us, and I hope we make this contribution towards it. And I also communicate my utmost regard, respect, and admiration towards you for blessing us with your presence on this day. Thank you, sir. Moving on further, I would like to invite Professor Sunil Kayas, who is also the convener of today's symposium, to share his experience with us. Please, sir.
It's very difficult because Professor Kamal has already shared everything and we are getting late. So I will not speak a lot. I would like to welcome you all that you came here to attend this one-day international symposium. I would like to say thanks our speakers who have just, with a very short notice, they have come here to deliver their talk, and I hope their talk would definitely strengthen our mission, our national mission, that is Viksit Bharat at 1947. And in some area, we are definitely more than any developed nation, whether it is a space mission or health sector and a different perspective, we can see that we are not much behind than the developed nation. Yeah, there are certain concerns where we have to grow at a lot to develop a complete developed nation. So with this short note, I would like to welcome you all uh, on this one-day international symposium. Thank you so much. Now, I would like to ask our anchor to proceed further without any delay. Thank you.
Thank you so much. Your passion for science really came through your words, and we are all grateful for the knowledge and inspiration you always share with us. Thank you so much. Now I have the privilege to invite Professor Indrakant Singh, our teacher in charge, Department of Zoology, and also the organizing secretary of today's event, to share his thoughts with us.
Thank you, Dr. Jaya. Good afternoon, one and everyone here, respected guests, senior most faculty, and my dear friends and students. I don't want to come in between the speakers who are already, we are getting late from the schedule plan. But yes, I just always quote and to start with all the events wherever I involve with Swami Vivekananda. As you say, the theme of this conference is Swasth Bharat, Viksit Bharat. Under that theme, we always understand if you want to love someone, we have to love yourself. To love yourself, it is always important to take care of your health. And because I don't want to quote or unquote wrong words, so I just wanted to quote one very important aspect from Katha Upanishad that say, Nyay Matma Balhinain Lavya. This self is not to be attained by the weak. So the first build up your own physique. Here, physique means health. Then only you can get control over your mind. So that's very important. And Vivekananda always say, he who wants to become a bhakta. Bhakta means disciple. Bhakt must be strong, must be healthy. So that's why it's very important to know about our health, advances in health sciences that will help us to keep ourselves healthy and keep our mind healthy to contribute to our family, to our country, and to the world. Thank you. Thank you so much.
Thank you so much, sir. Your insights and perspectives were truly valuable, and even your contribution to the success of the event is highly appreciated. Thank you so much. I also have the privilege to invite Dr. Aditya Saxena, IQAC, coordinator of Deshbandhu College, to please come and enlighten us.
Thank you, Dr. Jaya. First of all, I would like to welcome Dr. Veeranut, Dr. Ashish, Dr. Roshan. He'll be joining us after some time. And especially offer our thanks to Professor Ramesh Goyal, sir. All of you, I welcome all of you to Deshbandhu College and to this International Symposium on Advances in Health Sciences. Also, I think it's really praiseworthy that Department of Zoology is organizing this International Symposium. So my congratulations and best wishes to Professor Kamal Gupta, sir, Professor Sunil Kais, sir, Professor Indrakant, sir, and all the other faculty members of Zoology Department. And also, I would like to welcome all those people who have joined us online because this International Symposium is being held in the hybrid mode. So I also welcome all the people who've joined online. to Deshbandhu College and best wishes for this symposium. And I'm sure that this symposium will really go a long way in fulfilling the dreams of Viksit Bharat at the rate 2047. Thank you.
Thank you, sir. We would like to thank you for your presence at the inauguration ceremony of the symposium. We really appreciate you taking out time for us from your busy schedule. Thank you so much. Now, moving on to the first session of the first speaker of the session today, may I have the privilege to introduce Dr. Ashish Avasthi, Senior Scientist at CSIR Central Drug Research Institute, Lucknow. Sir has done his education in biostatistics from Sanjay Gandhi Postgraduate Institute of Medical Sciences, Lucknow. He also holds MSc degree in epidemiology and biostatistics from London School of Hygiene and Tropical Medicine, UK, and the other from the Banaras Hindu University. Previously, he has also served at many places like Public Health Foundation of India, Gurgaon, Center for Chronic Disease Control, New Delhi. Sir has been editor and reviewer to many renowned publications like Clinical Epidemiology and Global Health, the Lancet Global Health, to name a few. Sir has over 110 publications and citations of around 98,000. And he has been honored with many awards like the recently Commonwealth Distance Fellowship for his support to the future global leaders in respective areas, and also Professor K.R. Sundaram Young Research Scholar Award for exemplary research work during his PhD. We are honored and privileged that you are here. I would like to invite you for the session. Thank you so much, sir. There is just for the students and participants that there will be a question round at the end of the session we would be having for both online and offline. So please do not interrupt and keep your phone on the silent mode. Thank you so much for your patience.
Thanks a lot. मैं दुश्मन की साइड से हूँ. Numbers are your biggest fear. I ask everyone whenever I meet a biologist or life science or zoologist. They say we fear from numbers. So I try to minimize numbers and formulas in my slide. I will not show my work, although it is supposed that I have to show advances in biostatistics or statistics. So I will show the basics which we miss in statistics actually. So instead of going towards the advances, we should focus on what are the basics we should not miss. So as everyone said that we are targeting for Viksit Bharat into 2047. So India started independence, and after independence, we established 5 years plans and Indian Statistical Institutes, and that is led by Professor P.C. Mahalanobis. And statistics is only second subject which have dedicated Indian services. One is Indian Economic Services and second is Indian Statistical Services. No other subject have that privilege. So that's the overall gist. I will not show a lot of things. There are a lot of jokes actually on statistics. You can give me mouse. You can give. You can give me keyboard. So the most famous is there are 3 types of lies. Lies, damn lies, and statistics. You must have listened it. Another one is a statistician can have his head in an oven and his feet in ice, and he will say, I'm feeling fine. So these two are most interesting things, but I will start with another one. In God we trust, all other must bring data. So if you are doing applied research, you have to face that demon. The demon of numbers, formulas, and all the process. If you are submitting a research paper, most probably you will receive statistical comments, and it starts from basic, not from the advanced. So in statistical books, I have only 5 myths and 5 realities. That's enough for my today's lecture. And anyone can ask question anytime. You are free to interrupt me. So in books, most of the books, the definition of statistics is collection, compilation, analysis, tabulation, interpretation, and presentation of data. But what is happening before the data collection? Suppose you are doing a survey or your experiment and you have collected a wrong data with the wrong design. And you did that research for 5 years. So after 5 years, you receive the comment of editor of journal that you should do these things, not this thing. So whatever you have done in last 5 years, that is waste. So instead of starting from data collection, statistics is planning and design also. You have to plan your data, that what you will do, what is your study, and how you will collect the data. That is the most important thing. If you have issues in data entry, or if you are categorizing a data, suppose you are doing an animal study and you are taking weight of mice or rat, whatever animal you are using. And initially during the original data entry, you have written weight as less than 200 grams. And while submission of the report and submission of the paper, editor is interested in mean of weight. You can't go back in the time. So you have to take care when you are doing your study and planning your study, whatever measure you are taking, that is enough for your future use. Also, one important thing we generally miss, that categorization of data loss a lot of information. So if you have a continuous variable, note down as a continuous variable, you can categorize anytime later on. That is possible. Another problematic area is randomization. People believe that if you do an alternate allocation, that is a randomization. I have a question. Suppose in India versus Australia final, instead of tossing a coin, this time Australia played first. Next time I will invite India first. Is it acceptable to you? Or based on the date of birth of captain, whoever is younger, I will invite him first. Because it is happening in the research actually. So if you are not happy with in a cricket match, so why you are doing this thing in your research? That is a question. Based on the identification number, if odd will come, I will put in treatment group. If even will come, I will put that animal in the control group. Or a animal who is moving fast, I will put him or her in a treatment group. That is a general randomization people do in animal studies, but that is not valid. In clinical trial, randomization started in 1940s, and streptomycin was first drug where the proper randomization was done. So the original reality is randomization is different from haphazard allocation. It is reduced bias. It enhances and ensure that all participants have equal chance. The process should be repeatable. You can use statistical tables, or Excel is also helpful. You can generate random number table in Excel. There is no need of sophisticated software for random number tables. But you have to ensure that you have done a proper randomization before starting a study. The last graph is from my place, the CDRI. I have not included author's name. In general, it is a practice that we will put 1 star, 2 star, 3 star. Software is not providing 4, otherwise we will put 4 star also. The first is if your calculated p-value is greater than 0.05, we will accept a null hypothesis. In statistics, a null hypothesis is tested for possible rejection. We can't accept a hypothesis. Either we have enough evidence to reject it or do not have evidences to reject it. There is a no acceptance of a hypothesis. P-value is good for a publication. As a statistician, I say it is not mandatory. You can publish a good research paper without using testing of hypothesis, but your objectives will support that. If you have a different type of objective and you are playing with a sample instead of a population, you will use null hypothesis testing. Otherwise, it is not required at all. If everyone is using population, the statisticians will be jobless. So if you are playing with sample, only then statistics come in place. Otherwise, my subject have no importance. So the reality is, H0 is tested for a possible rejection. There is a no acceptance. Either we will reject or not. The statistical testing supports your objectives, and this thing, the 1 star, 2 star, 3 stars, basically while calculating the sample size, you fix your alpha and beta, that is level of significance and power of test. And once you fixed your alpha and beta, your entire study should follow same thing. So if you have supposed started with 5% level of significance, you will use only 0.05, not 0.01 or not 1.0. So that is the basic gist. And in this paper, we have not used any statistical test. And its impact factor is more than 13. So statistical testing is not required if it is not used in your objectives. That is the main gist of the story. Another major problem in the statistics is calculation of sample size. In most studies, either it is not calculated, we will take 5 animal in control and 5 animal in the treatment group because everyone is doing same thing. That is not a proper way. Another formula, I will show some formulas now. You don't need, no need to remember is this formula, that is for the prevalence. ये रामबाण है. In most of the papers, you will see only this formula, but you are not doing a prevalence study. That is another problem. Or we will follow a sample size which is shown in a paper. That is also not a correct way. Professor R.A. Fisher, if you remember p-values, you have to remember this man. He has given concept of ANOVA, design of experiment, and statistical testing. He said in a keynote lecture of Indian Statistical Association in 1930s that if you are consulting a statistician, After your experiment is over, you are doing only a postmortem. I have shown 4 formulas here. All these are for sample size. The first one is for proportion, single proportion, when you are doing only a prevalence, single prevalence study. Second one is only a single sample t-test. Third one is independent sample t-test. Fourth one is comparison of 2 prevalences. Whatever statistical analysis you will use in your paper, sample size will be calculated for their formula. So there is a one single shot sample size formula. If you need help, you can take from WHO manual for sample size calculation that is freely available on WHO website also. You can use that. A lot of formulas as well as sample size tables are there. You can use that for your sample size calculation, or you can consult a statistician. Both our options are open. There is another issue. When we do repeated samples, suppose we are doing and developing a new method for some readings, either it is PCR or doing something else, generally we either do comparison of mean of both the groups, or I will show the data. I am from a medical background in training as well as in public health. So I have only these kind of data. So basically this is PEF from 2 different meters, and general perception for this kind of data is either use comparison of mean in both the groups, or calculate a correlation, or intra-class correlation, or standard versus different new method. So I have done a calculation also. The first one is mean of one method. Second one is mean of second method, and there is no difference. I have a p-value more than 0.05. So my null hypothesis is rejected, and I will conclude that both my null hypothesis is not rejected here, and my conclusion will be both the measurements or methods are same. I have done another calculation. I have calculated a correlation coefficient, and the R is 0.94, that is near to 1, almost perfect, with a p-value less than 0.05. So we have a very significant correlation. Again, we will say that both the measures are almost perfect, and we can replace earlier method with the new method. I had done a regression also, and my R square is 88%. So the overall variation explained with the variables is 88%, and that is again significant. So I have done calculation of mean, calculation of correlation, and calculation of regression. All the measures are saying same thing, that okay, you can replace old method with the new method. There is another measure, a simple measure where on x-axis I have plotted average of both the readings, and on y-axis I have plotted difference of both the readings. And ideally, if we can replace the first measure with the second measure, all the values should lie on the 0, because there is no difference. We have established this thing earlier, that there is no difference in measurement. But if you observe, it is from minus at t to plus at t. So first thing, there is a statistical significance. All the values lies between limit of agreement, but the statistical limits may not be true for your experiment. You have to take care of it also. Suppose I'm taking your pulmonary function, that is the data set, And one measure says it is plus 80 and another measure says it is minus 80, I will say something is problematic there. So these are two graphical methods which we have done. Everything is synced here. And it is showing that we can use new method instead of earlier. We have used this method in a different paper published last year in EGFR estimating equation. We have also done correlation. There is a perfect correlation between earlier equation and new equation. EGFR basically estimate your kidney health. So there is a perfect sync that the old equation and new equation, we can replace old with new one. But we have another plot also. And this plot says there is a bias. Initially, it is increasing. Later on, it is decreasing. So there is an inherent bias in a new equation, and we need more evidences to replace old equation by new equation. So we need less research actually, but done for better purpose and with better planning. Thank you.
Thank you so much, sir, for introducing us to the world of biostatistics. And I hope that coming up with the NAP, biostatistics has a very good role to play in the zoology honors and even the life sciences, biological sciences. So thank you so much, sir. It was an immense pleasure for us that you joined our event and bestowed us. Your precious time was of great importance for us. We were all thoroughly engaged and learned a great deal from your presentation. If there is any round questions in the chat box. Here in the conference room, if anyone has any question for sir, yeah.
You are referring these two graphs. This one? Okay. Okay, so original readings are basically estimated GFR that is normally distributed, and it is showing a perfect sync. That is the message from the correlation and regression. Okay, so in this graph, we have taken average as well as difference of both the readings. So actually the data is now a different from earlier normal distribution because we have two new variables instead of earlier two variables. And it is done because you are right that data distribution is different now. So that's why there is a bias. You can't say that it is a normally distributed one. It is something else. So you have to take care of that something else actually.
सर आपने कहा कि डाटा कलेक्शन के बारे में प्लानिंग की जरूरत होती है। मैं उस प्लानिंग के बारे में ही जानना चाह रहा हूँ कि उस पर क्या प्रिकॉशन हो। कभी कभी हिस्ट्री में ऐसा होता है, खासकर आर्कोलॉजिकल में, कि कंक्लूजन हम पहले से ही सोच लेते हैं और फिर डाटा को अकॉर्डिंगली ढूंढते रहते हैं। तो मैं यह जानना चाह रहा हूँ कि प्रिकॉशन प्लानिंग के लेवल पर क्या होना चाहिए, इसके बाद डाटा कलेक्शन शुरू होता है। थैंक यू सर।
Basically, the flow is downwards. And if we want to do a upward flow, so that is not statistics. I can't explain that thing actually. And entire statistical theory can't explain that because you have fixed your result, now generating data to support your result. You are not testing a hypothesis. You have a fixed result that there is a difference. Now you are generating data accordingly. So that is not a science, sir. You know it.
Yeah, I have just one observation and a query. Thank you, Professor Vasti, for giving such a beautiful talk and teaching some of the very, very basic in the most fascinating manner with this a little sense of humor also. And I remember we also used to do that many times. Averages are absolutely misleading. Like we say at place river, the depth of river is 2 meters or 1 meter and other 4 meters. So it comes to, let's say, 2 meters, and I can easily cross that because average depth of river is less than my height. But I just want to ask one thing because, first of all, I always say that science without statistics probably wouldn't satisfy the things, and statistics an integral part. And as far as the phobia is concerned, I think it is not. Sometimes, the best teacher is the one, best subject is the one which is taught good. I just have, because we also play with the number, I do research on the animal behavior basically, and any behavior with their statistics is absolutely incomplete. So as you say, the sample size, yeah, we do follow the WH protocols to calculate the samples. But many a time, suppose we are doing 5 replicates, in 4 we are getting null response, 0, and in 1 we got 1, let's say. So there, the average is quite misnomer. It comes to, let's say, 0.2. And if I put in the standard deviation also, it comes to 0.2 plus minus 0.2 or like this. So means it can be 0 order, all these things. So at that time, many a time, my students, I ask the students either go for more replicates or for the time being, in these type of observations, would like leave the extreme variable and then go. But at the same time, leaving extreme variable does not mean that does not signify anything. Maybe at later point, you can really work that if you are getting one positive, so why it is so. So I just want to know in these circumstances, basically, what is the right approach to do? Second thing is just now Dr. Jha has just mentioned about the reverse statistics. I don't know if the real genetics is there. If we are really going in reverse genetics, we are there. If we are really going for the reverse statistics. But yes, scientific screening is a biggest problem, as you just mentioned, that very often we chose the parameters or the data which fit in our hypothesis and we eliminate and they really disturb the randomness. So randomness is very, very important. But I really want to know your opinion, especially in the case where 5 replicates may be there, 4 are showing uniformly as 0, and 1 is doing 1. So that's the right approach. Thank you.
So if we have a small study and we have one extreme value, you are giving example of extreme value. The best way is do with extreme value and without extreme value analysis. I will go for analysis having a sample size of 4 and analysis having a sample size of 5. If my hypothesis is same and results are in same direction, I will conclude accordingly. Otherwise, I will note down that thing that due to one observation, results are different and we need more sample size to prove our hypothesis. That is the way I choose actually, because some people leave that observation, some people replace that with mean, That is also done by some individuals. The best way is do a sensitivity analysis, include all 5, drop 1, which is you are considering as extreme value, and do an analysis, same analysis, what you have done on 5 samples, on 4 samples, and check your result.
And then it can be compared.
If these results are consistent,
Okay.
then whatever you are doing, that is correct thing.
Okay.
If results are different in 5 sample and 4 sample, you may need more samples.
Okay.
Thank you, sir.
Thank you.
And for the second, your query, when we I read research paper as an associate editor of 2 journals. So I try to do forensic statistics. So I start with their results and try to check that if they have written that their study have 80% power. So I will try to check that it is giving me 80% power or not, first thing. Second thing, if they have claimed normal randomization instead of block randomization, in normal randomization, samples in each group will not be equal.
Yeah.
So if they have claimed a normal randomization and they are saying that we have equal samples in all the groups, then they are doing something else, not a science.
Yeah. Okay.
Thank you, sir.
Thank you.
Yes. Yes, sir.
Values 0.05, 0.01 and 0.001. Yeah, so these are the standard values. But sir, in some publications, authors have mentioned the p-values, that is the 0.0001. So
Yeah, that is 4-star.
yeah, 4
We may
star.
have a 5-star also.
Yeah. So please clarify it, whether it is correct or not, or
That is not correct, actually.
Okay.
I will say why.
in fact, I have one data with me in my mobile. I'm just going through that. They have mentioned the 3-digit
Yeah,
of
that's
0.
that's all kinds of papers are there, both all are published papers actually.
yeah.
So if we see this formula, suppose there is a alpha and there is a beta. Your p-values are basically dependent on that alpha. And while calculating your sample size, you have assumed some alpha. Either you have said that there is a 5% error or 10% error. Whatever you have put that alpha in your sample size calculation, you have to follow that alpha in throughout the experiment. If you have assumed 5%, entire study will be based on 5% only, because later on you can't change. People are doing these things.
Limit for the accepting null hypothesis. That means
Null hypothesis, if we take real statistics, so there is no cutoff. If I can justify that I have very less resources and I am putting my alpha as a 30%, so that is very with a note that and pinch of salt that I don't have resources, and I have calculated for alpha is equal to 30% only. I have clearly said, so my result should be read in that context. That may not be true in next study because I have less resources. Any other question?
Thank you so much, sir, for the take-home lesson that do less research, but better research. Thank you so much. Moving on to the next session, I have the pleasure to introduce the speaker of our second session, Dr. Veera Noot, who graduated as a medical doctor from LHMC, University of Delhi, and later did her master's in clinical tropical medicine from Mahidol University, Thailand. She is currently working as an associate professor at the School of Allied Health Sciences, Walia Lak University, Thailand. Ma'am is actively involved in her research areas of interest like infectious parasitic diseases, diagnostic challenges, natural products, water-based research, and health awarenesses. She is also the coordinator of International Research Networks, Southeast Asia Water Team, and World Union for Herbal Drug Discovery. Ma'am is also the recipient of the Outstanding Scientist Award at the 9th International Scientist Award on Engineering, Science, and Medicine in 2020. Ma'am is also listed in the world top 2% scientists in the category of career-long citation impact and single-year citation impact in the disciplines of tropical medicine, mycology, parasitology, and clinical medicine. She is the first international guest scientist and has been featured in the Association for African Medicinal Plant Standard in June 2023. Last but not the least, ma'am has been listed in Thailand in top 5,000 scientists of 2023. We are privileged that ma'am is here.
How many minutes?
30 minutes? Yeah, 30 minutes.
When 5 minutes, and then you let me know.
Sure, sure.
Yeah.
I remember you came to the college once.
Okay.
When
So,
we were leaving.
good morning. A bit exciting. Okay, good morning, everyone, and thank you very much, for inviting me to be here again. Okay, as a DU alumni, I think I will be very happy to be here every year, actually, and very frequent that I come and visit, Desh Bandhu College, okay, with Department of Zoology, and now we are very close friends. Yeah. I think please come along with my memory lane. I just give you some idea only what of my work is on about when you talk about, visit Barrett, right, in 2047. I think nanotechnology is something that, is very important. And I think relevant to the present situations, and everywhere, every area, nanotechnology really play that roles, yeah, okay? So I think that just come with me and then see how we work. Particularly you are students, you may really interested to come to our lab, okay? So I really welcome you on, okay, to our lab at Walalak University, yeah. So you see that how the treatment of acanthamoeba, I think that you also may not be really aware of this parasite as such, So it's quite interesting actually when you talk about parasitology in terms of the medical importance, yeah. Okay, so treatment of acanthamoeba using nano encapsulation of selected Asian plant extract. I think we have a long story actually of this, Okay, there. Okay, I think since evolution, you can see that the parasites are with us, They are with us, they don't kill us, but they can cause just like unpleasant, okay? And also that they can weaken our health. So usually parasite and human, we are side by side, okay? They also stay with us, okay, inside our bodies. You talk about the anti-parasitic drugs, particularly that, as you know, that I did medicine from Lady Harding Medical College. So you see my background is about medicine, is about drugs, okay? So when I come back to this acanthamoeba, I also still continue with this kind of work, okay? So actually, when you talk about parasite as such, they're not really, people interested to work in this field. I think they should have some certain, reasons, okay, that, can pose dilemma of this kind of anti-parasitic drugs, okay? Just like that they are not on parasite, that you can go about it, and then they have some resistance. They're not a priority, okay, for the scientists or even for the what they call the company. And usually, that parasite actually is happens in a poor country, okay, just like in developing country like us, So it's a cost effective. It's about the risky affairs, So you can see that why parasite compared to other microorganisms may not be really spy as such, in terms of the anti-parasitic drugs, So you can see that even in the evolution time, I think even in the time that we have kind of the, we are evolutionary, right, ancestor from the monkey. I think there is some record that, our this the monkey on this, they also have, by naturally, they also use some of the plants that can help, okay, to cure their diseases also that have been reported. So what happened with the plant-based medicine? I think when you talk about plant, that's not something is very new. Actually, it's a quite long time already that have been used in the history of mankind, okay? But when come back to parasites, I think parasites also have been used as well, and then some of the plants also have been seen in the kitchens, okay? And that's automatically that, humans also have a chance that, to come across and then can use it, okay? And seem to be effective as such, I think among all the parasites, I just want to give you some idea, particularly malaria. Okay, malaria is one of the, Plasmodium, I think you know, right? That's a causes malaria, and they have about 5 types that is quite common in humans, yeah. So you can see on this, as a vector-borne, they are top killer, they are drug resistant, but somewhere, somehow, okay, they still have plants, okay, based medicine that have been, used and maybe very successful, particularly in the term, in the group of the artemisinin, and also that Prop UU2. Now, she is the one that has been awarded as a Nobel Prize, okay? So that's something that we are parasitologists, we are very proud of, okay? That at the end of the day, after so many years, okay, even now she also become old already, but that's how, okay, she had been awarded of these very prestigious, okay, awards, okay, in the world. So you can see that these also some of the plants that have been used, okay, for this anti-helminthic. But here you talk about worms, right? I think worms something that people don't like it, but they've been with us more than 4,000 years ago. It's supposed you talk about the mummy, okay? They have been, reported of mummy, okay, that have been seen, okay, parasites, okay, inside the mummy as well, okay? So another one that, we went to Brazil. So did we talk about the trypanosomiasis, right? They are two brother sister, okay? The cruci and brucine, okay? So this is the part as one that is very important parasites, okay? That have been reported, okay, in around the world. May not be commonly occur in our regions, okay? But that's also, have been, talked every day, okay? Just like they are routine in South America. So they are top killer disease as well. They also vector-borne. Yeah, they have two main species. But they are very unfortunate that not so many drugs, particularly modern drug, okay, that they have been discovered or they have been, want to find out, to treat these, parasitic diseases, okay. But however, they also still have some of the, kind of the compounds, okay, that they think that is very important, okay, to treat these parasites, okay. But at overall, we know that parasite had been classified as okay, as a neglected tropical diseases, okay, as such. I think as you know that because of the, kind of how geographical distributions of the disease, okay, and also that how the people that, have been affected, okay, so this kind of the factor really, have a play roles, okay, in terms of the kind of the definition of neglected tropical diseases as such. But you can see that now that there is some changes a lot, okay, in terms of, the content, the concept of parasitology, yeah, that particularly in terms of the investigations, diagnostic, matters that they have been, involved in so many ways, okay, not just only just go for the basic microscopic examinations, but also now they go for nanotechnology, they go for omics, okay, and also kind of a repurposing drug, etc., okay, that come into considerations, okay, nowadays. So you can see that now we also very, aggressive in terms of the, our own work, okay, related to the acanthamoeba. So you can see that now we talk so much about UN SDG, right, sustainable, okay, development goal. And this also, we are fortunate that we also have participate in this kind of the thing as well. So I'm going to talk a little bit, okay, I give you just some idea how our work is on about, okay, at least, you can get, idea, and then maybe you can, come to our labs and then you can pursue your own postgrad, okay, study. So we talk about One Health. I think as a medical, person, I think One Health is very important. Okay, this something is about related, interconnected between humans, animal, and also environments. Okay, so this usually is about our work. Okay, research activity that we form as a group. I think I have many things that to show you actually. So just come with me. Okay, and then this is about acanthamoeba. Okay, this is we talk so much about acanthamoeba because something is about the eye. I think eye is very important organs, okay, in the body. I think if you have no eye, that is terrible life, okay? Not just for humans and even in animal, I think life is really very difficult to survive. So this, everywhere when I go, this is the thing that I think you should come into your mind, particularly the people not work in this field. They may think that who, what, when, where, why, how, related to acanthamoebas, okay? That you think that maybe can answer you some questions of that. This talk about the monster, okay? The eye monster. This is one of the very famous scientists, okay? Prop Khan, okay? Navid Khan, I think he's the one that really worked so much, okay, from Pakistan, okay, related to this, what they call waterborne parasites, okay, with acanthamoeba in Nigeria. So you talk about acanthamoeba, you talk about environment, because this is a waterborne parasites, okay. So this is something that, they talk about the silent feature. All this, I think you can read, okay? You can read from literatures, okay? But one of the things that I can say that Kantimba is very important, okay? Not just only that they can cause disease as a localized, but the most important, they can go to the brain. You know that any diseases go to the brain, that is really life-threatening, okay? Life-threatening. So you can see that about the pathogenic side, actually, we have 3 groups of acanthamoeba. But the one that we are very focused, is about group 2. Because group 2 are the one that most of them causing, human diseases, okay? And that's very harmful. And since you know that this acanthamoeba actually is a waterborne, so usually it's the water, based, okay, research that also we are doing, yeah? And then they have 2 infective stages at the soil and the seed. So these are the main 2 targets in our work, okay, that we do it, okay, by using these selected, okay, Asian medicinal plants, okay. And this is some of the, prevalence, okay, that how the incidence of the disease, okay, that have been reported, okay, in, in anywhere, and particularly in Asia, okay, continents, okay, that you can see. Okay, so what happens that actually every time before I start my work, review article will be one of my point, okay, that I have to do. Okay, so this is the part that we do, particularly in Southeast Asia. So we can see that on this acanthamoeba can see anywhere, okay, can see anywhere, and particularly with the waters, okay. So if you can see, this is how the risk factor, you have a clinical symptoms, we have how to diagnostic. That's how we involve, okay, with our work. And then prevention and control, usually we will go back to the risk factors, okay? What is the risk? And that's how you have to prevent, okay, and protect yourself, okay? So this is the part that we do. And then this is another one. You can see that you number very little numbers, okay, that have been reported, but they may be underreporting, okay? So this is the thing that we have to be aware of, okay, and see the importance, particularly in the medically importance of the parasites, okay? I can go. I think it's not working. Okay, Ken. I think that when you talk about One Health, that's what I also feel that One Health is very important in terms of the veterinary concern, because I'm very animal activist actually, okay? Not just only I'm working on research. So usually I'm very concerned, okay? Whatever happens in humans automatically, because we are interconnected, we are very close to animals, yeah? So they have a chance of the transmission, cross transmission from human to animal and vice versa. So this also have been reported as well, that acanthamoeba not just only can see from the human, but also can go to animal, okay? They have been, investigated and also confirmed that among the stray animal, cats and dogs and etc., or even the wild animal as well, okay, that have been reported of these parasites, okay? Now we come back to the treatment, okay? Actually, that as we know, as a medical persons, I think that we all mostly are concerned with the modern medicine, right? So modern medicine, actually, there is a pros and cons. I think everything in life, there is a pros and cons. Either you are more pros or you are more cons, right? Okay, but for acanthamoeba itself, actually, the modern medicine is very good. Okay, so far, based on our work, modern medicine is still the best. Okay, but however, we still want to try for the alternative choices, okay, if we be able to do it, okay, because this also for the treatment is quite long time, at least about 4 months, okay, average about 4 months that you have to treat. So that is really, take a lot of time, tones, and on the money, etc. Okay, I think based on this person, okay, he's very good. He's very good and very close to us, because we are in the same group, Christopher, okay, he's the one that writes so many international books, okay, related to these, plants. That was one of the reasons that I feel that I should be come into this field, okay? And then you can see the history later on, that how can I be involved with on these plants, okay? And this also World Health Organization so have been also support, okay, particularly in any research related to the plants that have been, evidently proven, okay, not just really talk out of the blue, but you should have evidence based, okay, and that's how I think World Health Organization really support, particularly at the time of the COVID-19 pandemics, okay, since we don't have so much of that. I think this one go back to the time that I just joined to the, Walalak University of Malaya in Malaysia. Okay, so I form a group, okay, as a seawater team, that's Southeast Asia water team. Okay, we have about 6-7 countries, okay, to work on waters, yeah. So this is how I started this waterborne parasites. Yeah. So then we have another, you know, just a small of the reviewer. Okay, we can see that how the plant-based therapy that have worked on the parasites. Okay, and then we also come to notice that acanthamoeba is one of the main parasite that people really working on it. Okay, so this is very good, and usually it's our objective in general that we do. Actually, we just selected. Okay, the one that have the antimicrobial property of the plants, okay? And then we come and taste it, okay? And see the phyto, you know, on the phytochemicals. And also we also try to intervene using this kind of nanotechnologies or in silico study, okay, as such. So that's how we work. So you can see this on our work, okay, less or more, okay, related to the nanotechnology, yeah, okay? And then this how we know about the nano is animal testing, because I'm the one that I'm not really support for the animal testing. Okay, so that I write a small okay, of the, you know, what they call the kind of the writing on this, you know, animal testing, good, bad, who knows. Yeah, so I think it's depend related how you work, but for me I prefer nanotechnology just because of I want to avoid this in vivo study. Okay, so usually I put the reduce, refine, or replace. So usually on my work are the replace work, okay, through the nanotechnology one. Yeah. When you talk about nanotechnology, think in brief, okay? Nano actually is another, you know, what they call kind of the choices that people use it. And you can see nowadays that nanotechnology really imparts, okay, to many fields, okay, in terms of the research or even in the commercial as such, yeah. So nano approach actually is a biologically potent compound that use either extract or we use as you know, compound that we use it, okay, for this nano encapsulations in our works, yeah, okay. So this is a gold nano, okay. This is the first time, okay, in University of Malaya that we use it, okay, for the gold nano through this Dr. Tuba. Now she's an assistant professor, okay, in UCSI in University Malaysia, okay. I think because of her work, okay, under our supervisions, that's why I really go through this nano, okay, and with the collaboration with one of the very good persons, okay, come through from Saudi Arabia to help us, okay, for the work of the gold nano. I think as a medical doctor, I don't think that I will know everything, right? But I think through these research collaborations, that's why I came to learn certain things, okay, with the certain techniques, etc., okay, to help up, you know, to make our work become more concrete, okay, and more acceptable, okay, and also validated, okay, by the people that they are really good in their own fields, yeah. So this is the one that we do for the, you know, we have Leo Indicas, right? This is from Christopher as well that, you know, suggests us to try with this, with her PhD. So she converted from master to PhD, okay? So this is the one that's, you know, very good that she can do very well with the soil and the seeds. I think as you know that actually the soil and the seeds are quite different, okay, of this acanthamoeba, particularly with the seed form, because of they have a double wand, okay? Double wand, that's why usually the drug that very difficult to penetrate. So this is the part that we really, you know, look at it. We want to focus it because most of the drug, okay, even with the plant as well, that can be easily penetrate for the soil because they have only single wand. But the seed one, they have double wand, okay? So that's difficult, okay? But this is the one that I can tell that certain things that they can work at the same time, okay? Even though not very good, just like a highly 90% inhibition. But however, we still can feel that it's quite approachable, okay? And promising as such, okay? So this is the part that we can see. And another one, I think she's very good that she have two plants, okay? Promising plants that, you know, we also, you know, come to what they call into consideration, and she can publish it off, okay? So this is about the gold nano, okay, preparations of that. Okay, this is a gold nano. That is the second one, pericosines and butyrenic acid, okay. We have about 3 compounds, okay, that we use it, okay, for the gold nano. Again, this acanthamoebas, okay, triangularis. Actually, triangularis is the one not very common compared to other strain, just like castellani. That's a clinically proven that have been, you know, create problems, okay, in human, okay, diseases, okay. However, I think this also can move and can tell very well that okay, the selected of the plants and also with the compound under nano encapsulation is work well, okay, again this acanthamoeba, okay, with the cytotoxic city test. And usually cytotoxic is very important because we want to see that, okay, make sure that it's not good. It's support, let's say in the future, it can be commercialized, okay? But it's support is proven that cytotoxicity is not harmful to humans. So it's quite, validated since the beginning, okay? So this is the part that we do. So this is the garlic acid, another one. So you can see from her work itself, that we really do very tedious in our work. And particularly we do SEM, we do TEM, okay, in order to see the morphologies, okay, of the plants as well. And do we see apoptotic, okay, effect as well. Because this is the one that just like, whatever you do for nano technologies, you have to really, confirm it, as such in certain level. Now, when I come back to Walalak University, so what happens is, okay, in 2017, okay, we also try again to do the review work, and this on the area that now we expose this, okay, we expose it in terms of the clinical, we have the clinical strain, okay, and we do the microscopy, we do the culture, we do molecular, in terms of we do for the confirmation, we do the phylogenetic, okay, of this, we do the sequencing, we try natural products, and then we do in silico study. I think now in silico study is very common, right? Particularly people that working in pharmaceutical sciences, okay? And then we do a nanotechnology. We do the, we try going to do proteomic in the futures, and then autophagy, that we have the people that, really expert in the field of the things in One Health, because whatever we do, we think that is good for human, we try in animal, okay, at the same time. So this is how we collected the water from our university, okay? And then we try sequencing, so molecular sequencing, and then we see how is a crate of that, okay? And finally, it's confirmed that we got Acanthamoeba triangularis from the water, okay? So that's the environment. So this some of our work that have been published, okay? Using this plant-based, okay? Once the curcuma longa, I think right, turmeric, okay? And then we use a different of turmeric, okay? In terms of the, how they work, okay? Against this Acanthamoeba soil and seeds, okay? Through the experimental, model, just like we do on the plastics, okay? Because we cannot really go to the eye as such because we don't have any clinical cases so far, okay? So we have to try as a model, okay? So we do, and this is how the what they call is autophagy, and so that we do. We have very good persons that if you interested, you can try with the autophagy how it work, okay? Again, this I can never, but induce some of the certain circumstances, okay? Particularly the environmental circumstances, and then how it work, okay? This how the undernutrient starvation, etc. Okay, so this is the one. This is the one that I'm very interested. Okay, it's a mangosteen. Okay, that we use it, and that's how we pursue further for nanotechnology. I think besides that, we use it, okay, to use against trophozoite enzyme that work very well, and particularly that you can see through the SEM. Okay, so usually on our work, I have to confirm with the SEM to see how the morphological changes, okay, of the parasites, okay, under, on this kind of the plant that we use, okay, and then get treatment. We have to compare as well between before and after treatments, okay? And we have negative and positive control, okay? So this is the part that we do, yeah. And now we go for in silico for this propolis, because we got the propolis from Iran, okay? That seemed to be very good, okay? And now we also have our own propolis as well. And we also send to our Dr. Chang Muga in the south, okay, doing this chitosan, okay, for the nano encapsulations, yeah, okay. So this is how the 3R involved, okay. I think as I mentioned to you, I prefer the replace of our work, okay, in order to make sure that, okay, we're not going to do any harm to the animals. Now I think they talk nanotechnology. I have to talk about liposome. They talk about niosome, okay. I think turned out to be one of our junior very good in on this, okay. So that's why we go for the niosome with this, okay. What they call Garcinia mangostana mangosteen, okay. And this have been published recently on the nano scale, okay, from the Royal Society of Chemistry, okay. So this is the part that now we do, okay. We under on this process, okay. And then finally, I think we also can get on this SEM. We see on the size, okay, of the encapsulated, okay, plants, etc. And then we test it again on the parameter of the, nano, yeah, in order to make sure that it's not going to have any kind of the bias, okay. And then we see that it really worked well. It's worked well, particularly that we see that after you have encapsulated, how long that you can keep, and the efficacy of that, how long it can be, can be validated, okay? But finally, we also can see that it's very interesting that now within a month, you still can keep this nano encapsulated very well. Okay, they still can give you the similar efficacy, but not longer than this. Okay, so this is something that I'm very interested because you know why, as the drug wise, I think we cannot keep very long, right? So usually they will have kind of the, you know, expiring date, so whatever. So this also can be another area, another point that I think we can try and then see from our plant that have been tested, okay, so far. So this is a very good, this is a morphology. You can see what's the difference that before and after treatments, okay? So this is the part that, you know, we can see. This is another one. We already finished our work about Kanima. Kanima is the best plant so far, okay, among all the plants that we use it, okay, against Acanthamoeba. That can work nearly about 99% inhibitions, okay, of Acanthamoeba triangularis, okay. So this is the one that we do, and we also confirm with the in silico parts, okay, both the in silico and also with the, you know, what they call the MD simulation as well. So we have our counterparts also from Bangladesh. So you can see that our work actually is something that, you know, we work with anyone that they really want to help us, yeah, in order to make sure that, okay, it's work well. So I'm fortunate enough that I have now about 2 staff, okay, from the LSU, okay, from the Philippines that willing to work on this Acanthamoeba and using nanotechnologies, okay. I think Prof. Hassel is already came to our lab, okay, and done initial parts already. And I think in April, we will go to China to try isolation, okay, for our plants that have been very promising as such, okay. So this the one, this is another girl from Portugal, okay, that's coming for master, okay. So she's going to test on the Portuguese plants, okay, and then against Acanthamoeba as well. So this is the one, I think as alumni of BU, I can tell you that India and Thailand, we are very close, okay, very close, not in so many ways, yeah. And we also get many benefit from India as such, you know. I can tell you that I'm also scholarship, okay, for medical scheme, okay, from India government. So I also have take really a good, you know, I keep very well. He also, I try very hard to get a scholarship from Walalak, and I didn't make, he also got it. And now he also completed, okay, with his work, okay, on this, you know, a different one, but it's about the silver nano, okay, nanotechnology on Acinetobacter baumannii, okay. I think just in last month or somewhere that they told me, Piaget, that is one of the topmost, okay, read, okay, of the paper of him, okay, after he's, you know, published. So I think it's very good, okay, as, you know, we try to support particularly on the Indian students, okay, in any way that I can do, yeah. And this is the one that I mentioned to you earlier now, that propolis that we sent to Dr. Changuga, okay. This is the first time that he did, so still not successful. So now that he going to try another one, yeah, in order to make sure that on the side, everything should be all right. And then we will further testing, okay, for Acanthamoeba with different strains of that, yeah. So you can see that I have so many collaborators from India, particularly since I, you know, what they call, I graduated from Lady Harding, and then now I still continue for research. And then you can see that I still come back here, okay, and then I will go to Jammu, and then I can see that so many, yeah, so many, you know, friends and etc. So this is our petty patents, okay, that we do it, we apply for it, and then we receive. And this is how we have another collaboration with different countries by getting on the plants, okay, or nanoparticles, etc. Okay. So if you interested, you can come and visit us, okay, and then we test, okay, we see how changes SEM, etc. Okay, this is from UCSI that we got it, yeah, and then it's very promising actually, yeah. So this is the somehow that it's really work wonder what I can see. Okay, this is a propolis. Okay, and this is how the water of the one world, one health. Okay, we get water from different, and now it's a 5 country already that I got. So we want to see how the phylogenetically distribution of the, you know, the parasites, okay, from different country. So you can see that when I go everywhere, I'm not just go, but I think that I have something in my mind that I have to take something back, okay, to Walalak University, and then I try, okay. So this is the part you see, we try to culture to be pure culture. And then it's really success in that sense, yeah, okay. And this is the one we got from Brazil, we got from China, and then we went to Russia, okay, and then we got it nearby, okay, at the St. Petersburg through the contaminated snow, okay, a snow one, okay, and turned out to be that there is something is there very promising, and we think that sure this should be Acanthamoeba as well, yeah. So this is about One Health, okay, so this is for the animal. Okay, we also for the animal day. This is the part that I would like to share with you. Particularly, you are the students. Okay, so this is the part that you can see. This how the collaboration through the WHO. Okay, World Union for Herbal Drug Discovery. Okay, we have so many countries, so many places, you know. And recently, I think we also be able to join with the African country. Okay, through the NAPICA. Okay, so this is how the thing we do. Okay, we have so many activities. Okay, if you're interested, you can join us. Okay, this is from Brazil, this from China. Yeah, we also mentor. Okay, I'm also a mentor for the staff and also for the student overseas and the student that have been successfully. Okay, in their own life. Okay, through my coaching. Yeah. Okay, so these are students. Okay, and this is the one. This on the activity that we have. Okay, so you can join us. Okay, on this. Yeah, it's very interesting actually. Okay, no more. Can you? Okay, thank you. I think it's, yeah, so many. I just want to have 1 minute to show you about the 2024 activities. Yeah. So at least this is the first one. Okay. And this is the second one for the Jammu conference among our World Union that we support. And this for the ASEAN Graduate Studies Summit in Thailand. If anyone interested, okay, in April, you please come. And this is online, okay, join between ASEAN as a president. And now they asked me to be the president of the Asian Society of Pharmacognosy, okay, in collaboration with this NAPRICA in on the 12th and 13th June, okay. And this is the one for online, and then I can circulate you in detail later, yeah, okay. This is the one, and this is our homegrown, okay, through Prof. Sunil, okay. That's the 4th International Conference, okay, on natural product and human health, okay. That will be held at the University of Aveiro, Portugal. You please join us in September, okay, 18 to 20. Okay, this is the one. And this is another one is our regular also that we will go to China, okay, for Hunan University of Chinese Medicine, okay. And this year is a very big one because in conjunction with 98th, okay, anniversary of the university, okay. So this is our Women in Science, okay. I think it's very important that we should support among women, okay, to be achieved, okay, in science, okay, on par with the man counterparts, okay. So this is the one that I'm very happy. So this is how I think in order to achieve in your work, I would like to tell you something about the research, okay, integrity in terms of transparency, in terms of the sincerity, okay, and responsibility. I think by generating this kind of the positive vibrance, I think we can work more in the futures, okay. Just like we are India and Thailand, okay, we are very close net actually, you know, and so many things in Thailand, in India that also we see in Thailand, okay. So I think that we still have many long years to go, yeah, in order to work together, okay, and not just only in research, in cultural, in traditions, yeah. If you go to Thailand, I think just like you move around in India itself, okay, and we also get many benefit from India, you know, when I go anywhere, just like the tourist places like this, you know, I still get very minimum, you know, fee, you know, that they provide from India government, okay. And as the Indian scholarship person, I think that is my role as well, okay, that I should support, okay, any Delhi University, you know, activity. Even my niece also now enrolled in the law school, okay, of Delhi University. So I think that just come visit our labs, okay, and then be part in our work, and then we move together, okay, particularly ladies, okay. So thank you very much, okay.
Thank you so much, ma'am. It was really inspiring. One world and one health, and working on specifically on acanthamoeba and talking about the natural treatment. I think it has opened a world, good new avenues for research, not even in this parasite, others also. And plus, you have also introduced us the visiting programs and collaborations that we can hold. And I think it is very inspiring for our students to come over there and work with you. Thank you so much, ma'am. We have any questions?
Ma'am, I have two questions. One is, are repeated sty infections of eye somehow related to granulomatous amoebic encephalitis? And can these be cured by fifth and sixth generation cephalosporins? So
I think something that is very difficult questions, you know, because I think when you talk about in terms of the treatments, I think it's depend on the since the beginning. since the beginning that you get the infected one, right? And then after that, after you get the treatment, you have to get the follow-ups. Yeah. I think when you talk about you mean the long terms?
Yes, ma'am.
The long term, I think it depends. I think it depends, it depends how your first time that you get infected, how the severity of that's okay. But I cannot.
Repeated sty infections can, may turn into some kind of granulomatous
I think
amoebic.
possibility is there. And even the blindness also can be there. It's suppose, you don't have proper treatments, okay? Particularly not proper treatment. But if you have under proper treatment and follow-up, I think you still can come back to the normal size. Yeah.
Ma'am, because it is once a person starts having a sty, it keeps on repeating because that's a Staphylococcus infection aureus, and that is really difficult to treat. Once you get and then you're gone, and repeatedly it will come.
Yeah.
So how to get rid of this?
One of the thing is that about the acanthamoeba, I'm talking acanthamoeba, is about causing any eye diseases. That what I can observe is that is under diagnosis. Okay, or maybe people not really interested in it because most of the time people will think about the virus. They think about the bacteria causes eye diseases, but not the parasites. So that's how this is become tangents, okay? Tangents disease, okay? By that you not really go through the right track, okay? The right diagnosis, okay? You just think that because of other etiological agents, okay? But not the acanthamoeba. So that's how it's very dangerous in the long terms, okay? The blindness can be there.
Are they correlated with each other, keratitis and dermatitis?
I don't
Because
think
both are skin infections.
I think that the majority of cases that we can see through the acanthamoeba is more in the keratitis in the eye. Okay. But other parts can be just a minor, maybe very rare. Okay. Very rare or atypical. Okay. Not really have been reported as such. Okay. But the most common one is a keratitis. Yeah. In the eye.
Thank you, ma'am. Thank you. Wonderful lecture, ma'am. Thank you so much for the information.
Any other questions?
We will discuss later.
It was a great pleasure to host you at our organization, ma'am. Your words of wisdom and your achievements have left a permanent mark on our hearts and mind. Your contribution towards science have made a positive difference in our community and beyond, and for that we express our deepest gratitude. Once again, thank you for gracing us with your presence, and we hope to have privilege of hosting you again in the future. We have more interesting speakers and sessions, but we would be taking a break for lunch. We have lunch arrangement for the teachers and the dignitaries in the zoology department, lab 2. And for our registered participants, you will be getting coupons, and the coupon is available outside where you got registered. I request you everyone to be present in the evening sessions. We have very interesting sessions coming up. Thank you so much. 2:15. We would be resuming at 2:15. Thank you so much.
Student, listen, student, hold on for a second. So after the lunch, you all should assemble here at 2:15. Okay? And attendance is compulsory and you have to submit the feedback form. Then only your certificate will be sent to you. So it's very important. Be on time, 2:15. Okay? Thank you.
So here you can see there are two cohorts. One is African American, another one is Caucasian. African American, it's basically based on, you know, skin color. Jinke skin color, if it is black, they are basically African American. If it is white, you refer them as Caucasian, right? It's not changing. Okay. So what is TNBC? As I mentioned, this is triple negative breast cancer. So when you see, there are different varieties of breast cancer, and there are basically 3 key receptors which is present on the cell based on which it has been characterized generally. So in this case, there is no estrogen receptor, there is no progesterone receptor, and there is the third one, which is basically HER2. This is basically for, you know, secondary messenger signaling and everything. So these 3 receptors are not present on the patients of TNBC. So agar nahi hai, in that case, the treatment becomes very difficult, you know. And in due course of time, people have seen this, you know, difference in different races. That is because of the genotype. There are reports. Next. मैं कर लूं? Okay. So there are reports where you will see that, you know, some of these patients, if they are in African American, their survival is worst in terms of, you know, overcome the disease. But if you see Caucasian women, there are reports that even if they suffer from TNBC, their survival rate is, you know, much better than the African American. Then the only thing that you think as a human, what is the major difference? The first thing is their genetics is somehow different, not entirely different, because both of these, you know, categories, they are human beings. So you assume that the differences are there in the genetic material. One is African American, another one is Caucasian. Likewise, then comes the socio-economic condition. We have this, you know, we see things, we analyze things, and we assume things. So there is one perception that, you know, if the people is living in United States or in UK, their socio-economic condition is much better than the people who are basically living in African countries or, you know, some parts of Asia. So by far, this is somehow, you know, right. And in terms of resources, in terms of availability of, you know, medical treatment, होता क्या है, इंडिया में आपको ट्रीटमेंट बड़ी आसानी से मिल जाता है. And in US, what same sort of stuff, you can die there because of cough and everything, but you won't die because of some sort of, you know, a different form of cancer. क्योंकि लोग उस चीज को उस नजरिए से देखते हैं that this is a big hurdle, let's solve it. So in this study, what we did, we had a cohort. One was African American, another one was Caucasian. We had 17 patients from African American and 19 patients from Caucasian. And this is basically their, you know, status of survival. When you see, in this case, you won't see the difference in, nothing is working. So this is basically survival plot. We called it KM plot, Kaplan-Meier plot. This basically tells you whether, you know, if you can see here, this is basically for Caucasian, this is for African American. It is not significant, but with all these things are basically, what do you call? One person died at this particular point, the other person died at this particular point. So this is basically their survival time. And when you see African American and Caucasian, this is a well-established fact that if this cancer is in African American, they have worse prognosis. At the same time, if it is in Caucasian, they are doing somehow better than the African American counterparts. So what we did, so the lab in which I am right now working, they have this, the question is, if you have variety of clips, some of them are made up of plastic and some of them are made of metal, how would you separate them? Everyone knows you can separate them by using magnet, right? That's the simplest philosophy. In this case, if you have a data set that is originated from human, 2 things you need to understand here. We are made up of cells, and the cells within the body has some sort of colonization coming from microbes. It can be bacteria, viruses, or anything. So you have both, you know, your cell as well as bacterial cells, which we call basically microbiome. So imagine a situation when you take out some tumor and you try to isolate the RNA, DNA, what sort of things. So if you isolate RNA, there is a chance that some of these sequences coming from human, and there is a chance some of these sequences is coming from microbes. So we have a well-established human genome which has been sequenced, and recently it has been updated. It means for every gene in human body, it's not entirely complete, but you believe that out of 30,000, 35,000 genes whatsoever there are representative sequences for that. So imagine a situation when you sequence a tumor, you have RNA from human host and RNA from microbe. What you do, you align it with host. Aligning means using the reference chromosome and then aligning the data. Data is basically ATGC sequence. So when you align it with the host, what happens? Whatever matches with human, the source will be human, right? Likewise. So in next generation sequencing, what we generally do, we have mixed reads. It is originated from human, but it has some sort of things coming from microbes, which are basically the residents of the host. So if you align it with the human host, it is basically known human reads, and there are some reads which comes from microbes. It can be unknown, it can be known. These both categories still exist. So whatever maps with the known, what you can do, you can use those reads and you can assemble them. The assembly is known as de novo assembly because that is not reference based assembly. So when you assemble, you can generate novel microbes. So this particular package, which is called PathSeq, it was generated by my postdoc supervisor, and they published it somewhere in 2011 in Nature Biotechnology. Because Nature Biotechnology is a journal where all the pioneer work in the field of biotechnology gets published. So this was a very novel idea at that particular time. So if you assemble, you can generate contigs, and based on contigs, you can decide whether the sequence matches to a particular virus, or there is some contig which is entirely different. Then you try to find out the open reading frames, which is basically the coding sequences, and based on that, you realize that you have somehow constructed an organism which is noble and which is a resident of human microbiome and living in human host. So that could be one sort of publication. So as I mentioned, if you go for RNA-seq data sequencing, so when you deal with human, you invest a lot of money in order to get sequence. So this is basically killing two birds with one stone. If you have RNA-seq data, what can you do? You can use the differential gene expression in terms of host gene, which are the genes which is dominant in African American, which are the genes which is dominant in Caucasian, and vice versa. Likewise, you can use this data to generate the microbial abundance, which are the microbes which is abundant in African American, and which are the microbes which is abundant in Caucasian. And then you try to correlate these data sets. Imagine a situation when you have a pattern, right? Everything goes with a pattern. So what we have done here, we have used this gene expression data, we have used the microbial abundance data, and we try to make sense out of it. So as I mentioned, there was one package that was generated, which we call PathSeq. So what we did, we used the RNA-seq data for 17 plus 19, because 17 was African American and 19 was Caucasian. So that RNA-seq data we used, and what we did, we ran this PathSeq and we generated the microbial abundance. And based on that, we did clustering of these patients. So when you see this is basically a phylogenetic tree, and you can see there is clear-cut two clades coming out of it. And this data basically tells you the ethnicity. So even if I see cluster 1 and cluster 2, one thing pops up in my mind, that in cluster 1, you can see this particular yellowish is somehow more abundant. The yellow color represents African American. Whereas if you see this pink color, this is somehow more abundant in clade 2, which is basically Caucasian. So even though we are using microbial signature, we can see a sort of pattern when we talk about the African American and Caucasian cohort based on microbial sequence. This is not host, right? And then we mapped all sort of data sets, and we concluded that there is some pattern which is basically race associated when we clustered the microbial data, which has nothing to do with host genetics. And then you do comparative marker selection. What is comparative marker selection? Compare two cohorts and try to find out which are the genes which is abundant in one group and which are the genes which is abundant in another group. So based on that, we came to know that there are few microbes like Sedacia, Hafnia. All these microbes, they were somehow more abundant in this particular population. This population is basically African American, right? So now I know there are some microbes which is specific to African American. There are some microbes which is specific to Caucasian. This is basically their, abundance across different samples. The next thing we did, we had RNA-seq data for human host. We tried to find out the similarity between the patients, because you never know, some of the patients, they are extremely different, even they come from the same, genetics. आपको पता है ना, कैंसर बहुत डिफरेंट होता है. One sort of therapy can work for one person, that doesn't work in another. So we wanted to see, based on gene expression profile, how these people or these patients correlate with one another. So it turned out there is two clear clusters based on RNA-seq data. These patients, they were somehow different as compared to the other. And in this case, you can see the pattern, it is somehow mixed. So one thing was clear, the microbial data was giving us some sort of pattern to delineate the African American and, Caucasian cohort. But the RNA expression data was somehow clumsy. It's like there is no clear cut pattern for this cluster, because this is the different cluster, this is entirely a different cluster. So there were mixed populations. And when you see patient and you plot their data set, you assume that there will be differences. As for example, when you see this data set, you will formally say that, look, this looks outlier, this looks outlier, means it is somehow different from the group. Then you have to go inside these, inside the data sets of these patients to find out what exactly is different in these patients. So we did some sort of, differential expression analysis. Differential expression analysis, it is a tool which, which takes in RNA expression gene counts, and then it tells you that, look, this gene is significantly different in one condition with respect to another, with p value and p adjusted value. So all these things you try to find out in order to get the genes which is significantly different in one population with respect to another. And then you do functional analysis, pathway enrichment analysis, to find out which are the pathways which is being mostly affected in these patients. I won't go into the details, but here we used a novel approach. What we did, we used the RNA expression data, and there were around 50,000 genes coming from human. And what and the next thing, we know that we use this RNA-seq data using PathSeq to generate the microbial data. So what we did, we used these data sets and we performed Spearman correlation. And what we did, based on correlation, what we did, we clustered it and we tried to generate 1,000 clusters, and we picked out those clusters in which human gene is clustering with microbe. So this was the strategy. Strategy was, look, we have genes which has differential expression, we have microbes which has differential expression. How can we merge these things together? So the idea was to mix their matrix. Matrix is basically a number, right? So you mix them, you cluster them. Cluster means there are algorithms that help you to, calculate that what is the probability of gene X coming with microbe X, So this sort of stuff you do using the correlation analysis. So we did correlation analysis. We divided that, entire tree into 1,000 clusters. And based on that cluster, we picked somewhere like 172 clusters in which at least one human gene and one bacterial genera were there. And then we further implemented some sort of analysis, and we tried to calculate the correlation values. And our correlation values goes as high as 0.7, and we segregated those pairs of microbes and genes which were clustering together. This is interesting, by looking into human gene, by looking into microbes differently, you can say for sure, you can say that, look, these are the microbes that is abundant, these are the genes which are abundant. But when you mix them together, can you notice a pattern where a gene is clustering with a microbe? In this case, we did it, and thankfully, we got some interesting results. So this is one of the cluster where you see that SPIDE2B gene is clustering with multiple microbes. And when you plot them to see, because if correlation value is high, sometimes it happens the data will be mosaic, and even one dot, if it comes here and another dot comes here, the correlation R square value will be really high. So we wanted to see what is the correlation between the gene and the microbe, and you can see we saw a clear-cut pattern of 0.77. So now we are in a process of validating this result, because we know this gene has some significance, this microbe has some significance. So these are basically the markers for this particular disease. We are now implementing wet lab experiments to validate this result, and how, what could be their impact. So using this data, we try to find their impact. So what happens? This is the most interesting slide. So what happens? We have seen that if you see the survival data with respect to survival probability, the African American, they are doing bad, and the Caucasian, they are doing good, right? When you use SPIDE2 gene and you cluster them, wherever SPIDE2 gene expression was high, these, this is basically low. Wherever SPIDE2 expression was low, these people were doing really good in terms of survival. Means जहां 10 हफ्ते जीने होंगे वहां 15 हफ्ते जी जाएंगे, ठीक है? But wherever the expression was high, उनकी survival probability खराब थी. And the same pattern we observed in case of Hafnia. Wherever Hafnia was high, their survival probability were bad. Likewise, wherever Hafnia was low, their survival probability was good. So this is the data set which we are currently validating in order to publish it. Then I mentioned we have another aspect which we will be dealing with, which is basically cervical cancer. This cancer is known to be caused by one of the virus, which is HPV, human papilloma virus. आपको वायरस के बारे में पता है ना, वायरस का क्या इन्फ्लुएंस रहा है हमारे मतलब लाइफ पे within like last 5 years. So this particular virus, it has multiple strains, and HPV 16 and 17, these are, sorry, HPV 16 and 18, these two variants or these two virus species, not species, these two viruses are basically the causative agent of 70% of the cancer. So in this data, what we did, we know that in cervical cancer, HPV is one of the main agent that causes all sort of genomic heterogeneity that leads to improper functioning of pathways, and finally leading to the onset of the cancer. So in this case, we developed a 3D model. What is 3D model? When you see a tumor, you imagine it is somehow spherical, some sort of, bulging stuff, right? So most of these studies till now have been done on cell lines. Cell lines, what you do? You just seed cell lines. There will be a layer of seed lines. You try to perform the treatment, and then you see the efficacy. You try to find out whether that particular drug is effective or not, some sort of. And what are the parameters you basically check? You check the proliferation rate, the toxicity rate, and all sort of things. But that is not the actual mimic of tumor. So in that case, what you need to do? You need to generate a tumor and then try to see the stuff, whether it is working or not. So in this case, we try to generate the 3D tumor from SIHA. SIHA is one of the well-known cell line that is used in cervical cancer research. So the first question which we asked, what are the differences in gene expression profile between two culture conditions, 3D versus 2D? Because it is obvious, when a cell is free, it has a different sort of environment. When a cell is adhered to next to another cell, everything changes. There will be some sort of matrix, in between the cell to cell, adhesion, and then all sorts of expression, because there are variety of receptors that is around the cell. When cell is freely floating, it has a different set of genes which is expressing, but when it is in a group, there is a different set of genes which were expressing. So this was our experiment. For 2D, we had flask in which SIHA cells were growing. We separated them. This is basically replicate 1, replicate 2. Then we use the another passage. Passage is basically if you are culturing a cell for like first time, that will be passage 1. If you are doing it for the second time, that will be passage 2, likewise. So what we did in every scenario, we generated 2 replicates for these conditions, and in total we had like 6 for 2D and 3 for 3D. We generated 3 3D and we tried to sequence them. We extracted the RNA. RNA is basically for gene expression analysis, which sort of genes are being expressed or not. And then when you isolate RNA, you send it to a company. That company has all sort of sequencing facilities. They help you to generate the data. Basically, the data is in the form of ATGC, right? And in case of RNA, from the RNA, they generate cDNA and then they're sequenced. So you have raw reads, you run all sorts of pipeline, and then you try to generate counts for each gene. Because by comparing those counts, you can say for sure, say that, look, this gene has a less count in one particular condition, this gene has a high count in another condition. So this is basically differential expression. So likewise, I told you, when we saw the patient sample, there were 2 groups. And when you see this cell line is somehow homogeneous. Patient is really random. So when you see a clear-cut pattern in 3D versus 2D, right? And then you perform PCA plot. Initially, when we included one of the 2D culture, it turned out to be entirely different from the rest of the 2D samples. So we had to take it out. I'll tell you the next story related to that in a moment. And then you perform all sorts of analysis to find out which gene is differentially expressed in one condition and in another. The idea, when you write a paper, the idea is to formulate questions and then try to answer those questions in terms of data, in terms of validating that data. So all these pathways were somehow up in 3D. All these pathways were down in 3D. So this goes on. And then you have to pick some of the genes which you think that it could be interesting and it is playing some sort of role. These are all pathway analysis. So the question is, I know for sure that in SIHA there is an HPV integration in chromosome 16. And there are adjacent genes which has been known to, express in high number because of HPV integration event. So the next question we asked, we know that HPV integration is there. What happens to this HPV gene expression when you use 2D versus 3D system? The results were very interesting. So all these genes, because it is a virus and sometimes this virus integrates few of the genes, as for example, E1, E2, E6, E7. So these are viral genes. This E6 gene interacts with RB gene of human. That is one of the oncogene. Oncogene? Yes. Yes. And then E7 interacts with P53. So there is some sort of equation of virus going on with human gene that leads to an event of, changes जहां पे आप बहुत सारे चेक पॉइंट्स स्किप करते हो और उस वजह से अ नॉर्मल सेल ट्रांसफॉर्म्स इनटू अ ट्यूमर सेल. सो हमें 3D में क्या मिला? व्हाट वी फाउंड दैट इन 3D वी हैव HPV genes which were really expressing very high as compared to 2D counterparts. One thing was clear, whatever model we were using earlier, now what we have generated is somehow better than what we had earlier. This was one of the conclusions. And then we use the same hypothesis. What we did, we used these genes and we clustered with all the human genes, and we made sure that, you know, when you compare these genes with human genes, there should be some cluster which you can further take out few genes to perform correlation analysis. मतलब ये होना चाहिए कि if one gene is really high correlating with another gene, that means something, you know. So we try to find out a set of genes that were correlating with virus genes. And you know, all these genes were differentially abundant across the 3D versus 2D. It was having the same pattern that we noticed in case of HPV. So means there should be some sort of correlation, and there is plenty of research going on all these things. So if in case if you cannot see it, the HPV gene is integrated here, and the downstream gene is KLF12. Okay, so when HPV integrates here, the downstream genes expression increases significantly. So that was one of the things that we observed when we were doing the analysis. So as I mentioned previously, there was one particular 2D sample which was behaving outrageously in terms of gene expression. So in order to complete the analysis, what we did, we excluded that particular sample. But later on, you ask yourself, what has gone wrong there, or what is different there? So the next thing we did, we used this particular outlier to find out what are the set of genes that is behaving differently. But you remember, I told you there was a clear-cut pattern when you see 2D versus 3D. The HPV integration, HPV gene expression increased significantly in 3D as compared to 2D. But in that one particular outlier sample, you know, this is E1, this is E2, this is E3, sorry, E6 and E7. E6, E7 expression was completely gone. You know, it was one of the event which you think if a virus integrates and you know somehow the mechanism through which you can silence, or you know, you can somehow wipe out the expression of E6 and E7 gene. E6 interacts with RB gene, E7 interacts with P53 gene. If this happens, that will be a sort of miracle. So we went back and we are trying to figure out what happened in this particular, you know, plating is there, everything is there, same passage was there. What is entirely different here? But what we did, we used this data and we try to find out the similar pattern. This is basically a screenshot where you will see here, this is the one sample in which there is an integration and the virus is there. You can see in another control, there is low coverage and loss of splicing as seen as above. So what we did, we used the same hypothesis. We had one outlier, and in that, the expression of HPV was down. So we try to find out what exactly this pattern is and what sort of these patterns are being followed by other genes. And we came across a set of genes which were following the similar pattern. Now we are investigating these genes, we are validating these genes, and we are trying to mimic what we have done so far. So this is the overall. Yeah, this is a list of genes which we are validating right now. That's it. That's, I think. At this point, I would like to thank Medical College of Wisconsin, my home institution, and the organizers of this event. Thank you. Thank you.
Thank you, Dr. Roshan, for such an informative and wonderful talk. I'm sure audience present over here are willing to take more out information. So now we have question answer session. Any question?
Very basic. you just, when you talk about the triple negative breast cancer, and that you mentioned that estrogen, progesterone, and third one receptors are altogether missing. So is it in a particular organ, or is they completely missing? And if they're missing, then what about the reproductive life? Because if estrogen receptor is not there, progesterone receptor is not there, then how the females actually work?
So
I know it must be a very, very basic question, but for my curiosity, I just want to know about
so
this.
the thing is that in this case, these are the patients in which, tumor has been isolated. They have been analyzed for the receptors on those tumors.
Okay.
Okay, it's not about other.
Okay.
So basically, related to these tumors, all these receptors were
Okay.
missing.
Okay.
And based on that, they say that this particular tumor belongs to TNBC, which is triple negative
Oh,
breast
oh,
cancer,
okay.
for which there is no receptor, and then the treatment become so much challenging.
Okay. And another thing is, like, you have taken two populations. One is the what you call American, another this. So even the social, the quality of life may be different in the two. So like the very first thing is, because what I feel you are mentioning about the African American, you must be referring to Negroid populations over there. And naturally, the quality of life is not that high as compared to the Caucasian population. So the life expectancy in these population, maybe because of the social factors, that is the very first thing needs to be addressed. And so, but there's some studies that it's not because of the social or.
Yes. So all these factors basically contribute to this. But the most important thing is, if TNBC gets detected in African women, they are more aggressive.
Okay.
Within like, if it is late to diagnose, and it gives you very less time. So the survival, by the time of diagnosis till treatment starts, there are a lot of changes that has been observed. And that's why you have seen that Kaplan-Meier plot, the survival probability is comparatively very less as compared to the Caucasian. And you are right, socio-economic conditions is one of the major aspect, because, if you have a good infrastructure, you will get detected earlier. And, the sort of understanding, the sort of all these things needs to be, because most of the time there is a hesitancy to talk about all these changes. So somehow this leads to that, and socio-economic condition is really a factor. In Caucasian, they are very much, they know how to express themselves. So it changes everything.
Third thing, like in this context only, since the microbes are also playing an important role in this, and naturally the quality of life in the two populations are different. So naturally the gut microbe or whatever may be different in two. So that's why in one of the populations it's precipitated at a higher rate as compared to others.
You rightly mentioned, the microbiome varies from age, diet, all these components significantly contribute to the change in microbiome. But the matter of fact is, here we are connecting microbiome with human gene expression. Can you imagine a situation where a microbe decides what sort of gene expression should be there in the cell in order to work properly or misbehave? This sort of.
Are there some studies in the Asian population also related to such similar studies?
If we talk about Asian, there is multiple studies coming from China. As far as India is concerned, there is not much of awareness, not much of funding. And we have higher institutes like AIMS, where, all these patients are there, but large scale study requires lots of money, which is lacking.
Just one question.
Yes.
Regarding that genetic, this difference between American and African American population, there has been many studies, especially in terms of these SNPs. There has been genetic susceptibility of these Caucasians people, means women, are much higher for this triple negative breast cancer and ER positive breast cancer, but as compared to the Asian and African population. But you, in your study, you are saying that triple negative patient, but has more impact on the African American population.
Yes, it is more detrimental in African American cohort than Caucasian.
But generally, the susceptibility rate of this triple negative breast cancer is quite high among the European Caucasian as well as in the normal Caucasian people as compared to the Asian and the African population.
Susceptibility rate is different from survival probability.
Yeah, I know that one.
Yes.
But have you checked the hazard ratio for that?
Yes, yes. That comes from, because this study is derived from 2 previous studies, which has been done on triple negative breast cancer. We are using the same cohort.
But how much did you get? But the size of the population for studying survival rate is quite less, because the number is around 17 and 15.
Yes, yes.
Yeah.
So this is a subpopulation coming from one of the studies which they have published that has around 76 patients.
Okay, yeah, that's why it's quite less.
That's why it was not significant. When I showed you, it was not significant.
Yeah, okay, thanks.
Yes.
Breast cancer, it is because looking at the two types, basic types, so because it's all ducts, mammary glands, so ductal carcinoma is one type, and I just want to know whether BRCA mutation is one of the major factors for
Ma'am,
triple negative.
so basically, it all starts with mutation and everything. But you know, TNBC, they characterize based on the receptors, which is available on the cell surface. And based on that, these 3 receptors, they are basically absent, and then they characterize that tissue, or whatever sample they, take out, they characterize it as a TNBC. But there are cancers where you will find the same cancer with multiple receptors there. So for them, the treatment becomes easier, and for this, the treatment becomes difficult.
Do you think in the near future stem cells can play a role in this? Because it's one of the most aggressive cancers, because metastasis is very high in triple negative breast cancer. Yes. So this can be, it's always an option. Yes. Thank you so much for the wonderful lecture.
I think we have one more question. Yes.
Sir, I read somewhere that cancer rates is 3 times higher in USA compared to like India. So what can be the reason, and what are the like survival rates? Is it higher in India or in US, as it is more advanced, or we can say? Okay. Yes.
When you talk about the rate of cancer, then this question is actually not complete. It should be what kind of cancer.
Okay.
Take example in India, lot of people chew tobacco, cigarette. Even if you go to villages, they do use khani. You will see lot of oral cancer cases. I am from Institute of Medical Sciences, Banaras Hindu University. And in our dental faculty, we see very many such cases which surpass other kind of cancers in other peripheral organ system than anything else. So it depends in what kind of lifestyle is being adopted there. Colorectal cancer. Colorectal is more in Western population. You will see it's not, it does not mean it that it doesn't exist over here. But incidences are more over there. Okay. So depends what kind of cancer you are.
Thank you, sir.
Very good.
Thank you, Dr. Roshan, for answering all the questions so patiently. So let's move further. We are honored to have Professor Suneet Kumar Singh from ACBR as chief guest of the valedictory session of today's International Symposium. Sir, we would like to thank you for your presence at valedictory session of the symposium. We really appreciate you for taking out time to join us this event from your busy schedule. Now, I would request Professor Indrakant Kumar Singh to welcome and felicitate Professor Suneet Kumar Singh. Thank you, sir. Sir, we value the knowledge and experience you will share today with us. Now, I would request you to take lead and address the gathering. I'm sorry. Yes, yes. Yes, I would. This is my immense pleasure to introduce Professor Suneet Kumar Singh. Sir is currently working as a director of ACBR, University of Delhi. He has done his PhD from University of Würzburg, Germany, in molecular infection biology, and his postdoctoral from Yale University and from New Haven University of California, Davis Medical Center, Sacramento, California, USA. He is a professor of molecular immunology and virology at the Institute of Medical Sciences, BHU. Currently, on deputation, he is working as a director in ACBR. Professor Singh led a research group in area of molecular virology as a faculty member at CSIR Center for Cellular and Molecular Biology, CCMB. He has published his research findings in so many international peer-reviewed journals, and he has published so many books also. Sir has been associated with many prestigious international journals as editors and members of editorial boards. Sir has received so many prestigious awards and fellowships, and he has contributed immensely in understanding the molecular pathogenesis of different vector-borne viruses. So now I would invite Professor Suneet Kumar Singh to address the gathering.
Good afternoon to all of you. Okay, my voice is quite loud. It becomes pain for listeners if I will use this. So I am avoiding that. Okay. So, my dear young, energetic, progressive, thoughtful students and my colleague here, Professor Kamal Gupta, Professor I.K. Singh, Professor Kayas, and if I miss somebody, because these names I put. Okay. So, thanks for inviting me in this temple of goddess of education. And I am very happy to be here. So, valedictory function is something in Hindi we say samapan samapan. But this is not samapan for you. This is the beginning for you, where you have been introduced to a lot of speakers. I think one of them, Dr. Roshan, was here before, just when I entered. And other speakers were also here. So you would have done. Today we are here, tomorrow you guys. Okay. So this is the phase of learning. We dreams. In Hindi, somebody said, सपनों का आना खतरनाक नहीं होता, खतरनाक होता है सपनों का मरना। Which dreams? Dreams of Professor Kalam, who used to say, those dreams which never allow you to sleep. Convert those dreams into thoughts and thoughts into action. Dream, dream, dream as much as you can. And don't stop till your goal is achieved. That is the dream. When I come on such type of occasions, I remember my days. My schooling got completed in very remote area, I will say village of this country. भारत गांव का ही देश है। मुझे इस बात को कहने में कोई गुरेज नहीं है, मुझे गर्व है कि मैं उस गांव से उठ के आया हूं जहां पर आपको सही सड़कें नहीं मिलेंगी, सही संसाधन नहीं। तो गांव की मिट्टी बड़ी उपजाऊ है, उसको जरूरत है थोड़े मॉइस्चर की, थोड़ा राइट तो वो सारी चीजें आप में से सारे ही लगभग ऐसे होंगे जिनकी रूट्स कहीं ना कहीं भारत के गांवों से। जब मैंने 10th पास किया, मेरे फादर के एक दोस्त थे और ही यूज्ड टू बी इंग्लिश लेक्चरर। तो उनको किसी ने बताया कि अगर आपका लड़का 10th पास कर रहा है, 11th में जा रहा है, he should go for mathematics, not for biology. The reason, then I asked what is, then at that time there were such kind of mindset, if you could get into MBBS only then you are successful, but if you couldn't get into MBBS, then there are very many other areas which you can join after having mathematics in that. My father brought these many books. I think he borrowed from somewhere because those were quite, pages were quite brownish. So, and he used to be quite tough. So he said, no, you have to do. I said, okay, let me develop a taste. So he had one friend and I used to take those books. Every day was calculus and integral of one, so on. So I used to go to his friend and he used to say this. Almost 10 days, I did this exercise routinely without using my will, because my father said me and I had to do it. But I couldn't develop anything. I thought, I want to study biology. Well, if you want to know about life, about death, about organ system, physiology, anatomy, molecular biology. So my father got quite, very angry on me and he said, no, you are not listening me, because my friend said, so mathematics is the only branch where you can do it. But I, just requested him, persuaded him, and at the end of the day. So what I want to say by this story, ये आजकल बहुत कहने को मिलता, हिंदी समझ में आती है कि अंग्रेजी में ही कांटी रखती है? ठीक है ना, पहले बता दीजिएगा, ठीक है ना, भारत में रहते हैं तो हिंदी तो बोलनी है। तो अक्सर ये स्टूडेंट्स डिस्कस करते हैं कि इस फील्ड का स्कोप नहीं है, उस फील्ड का स्कोप है, उसका नहीं है, इसका है। स्कोप वही है जहां आपका इंटरेस्ट, और जहां आपका इंटरेस्ट होगा वहीं आप नॉलेज एक्वायर करेंगे, वहीं आप स्किल एक्वायर करेंगे, और उसी स्किल इंडिया की भारत, उसी स्किल इंडिया की बात हमारे प्रधानमंत्री। जब आपका इंटरेस्ट ही नहीं होगा तो आप स्किल्ड होने के लिए उस विषय में आपका whatever you are doing, don't think about score. If you like it, if you can give your 100% to that area, I promise, I can bet you will be. Languages, sometimes you will see a person sitting to next to you is convent educated and he might be speaking English fluently. That is something else. Subject knowledge is, you know. You can express well in your Hindi, in your Telugu, in your Tamil, in your Kannada. You don't need. So, एक चीज कुछ भी आप करो, जब रात में पढ़ने बैठो एक पैराग्राफ पढ़ो, लेकिन एक पैराग्राफ पढ़ने के बाद जब उठो तो ये दिमाग में बना लो अब इस पे हमसे कोई डिस्कशन नहीं. Nobody knows better than me. This should be just spirit. You shouldn't develop proud. Remember, that is the distinction. You need to inculcate and you need to keep your, the skills of, the skills of your learning alive. So this is the way you will be successful. काम कोई बड़ा छोटा नहीं है. हमारे टीचर्स बैठे हुए हैं यहाँ पर आपके सामने, ये जनरेशंस को ये ट्रेन करते हैं, आपको भी ट्रेन कर रहा है कि कोई किसी फील्ड में निकला होगा, कोई किसी फील्ड में निकला होगा. तो आप ये नहीं कह सकते a person got A is superior than a person whatever got B. जो आपको अच्छा, जो आपको खुशी दे, जो आपको सेटिस्फैक्शन दे कि इसको पढ़ने में, इसको करने में हमें अच्छा लग रहा है और हम आगे ग्रो. That is your. Fields are not decided by anyone else. Fields must be decided by yours. And this all depends on you. And I hope that with the able guidance of these great teachers who are sitting over here, your other younger faculty members, you will achieve. You will attain goals. You should have those skills. I was discussing before 10 minutes with, I think, Professor Gupta and Professor Singh, कि भाई presentation चल रहा है, लाइट चली गई, PPT ऑफ हो गया, टीचर रुक गया कि नहीं साहब आगे नहीं प्रेजेंट करते, जब आएगी तभी. Presentation यहाँ होता है. You need to have a concept. You need to have a flavor. Those lines doesn't matter whatever is written on those beautiful flowery slides. You need to have a flavor. Just throw it, give it, share it. You will learn. So that should be. It shouldn't be your teacher taught. Now you are just memorizing colon, semicolon, full stop in order to get 10 out of 10. That is just you are reproducing it. You whatever they have taught you, you write in your own language, you write in your own sentences, and they are good enough and they will enjoy. Now you got it. That has been entered.
Thank you, sir, for enlightening us. Thank you for motivating us with your knowledge and experiences. We will definitely carry these lessons with us in the future. So, and thank you so much for coming here and taking out time to join us from your busy schedule. And I am grateful on behalf of Deshbandhu College. So now we are proceeding towards the end of the symposium. I would invite Professor Sunil Kais sir to present vote of thanks.
It's my privilege, I feel honored to be present here to give vote of thanks to all the dignitaries, participants, members of organizing committee. First of all, I would like to thank our chief guest, Professor Ramesh K. Goyal and Professor Sunit K. Singh. Professor Ramesh K. Goyal, who is a Vice Chancellor of Delhi Pharmaceutical Science and Research University, and Professor Sunit K. Singh, as you know, is the Director of ACBR. Our Chief Patron of the institution, Professor B.S. Chauhan, then our Honorable Principal as well, Dr. Devinder Kumar Pandey, Rajendra Kumar Pandey, I'm sorry, and our Principal, officiating Principal, Professor Kamal Kumar Gupta, who was officiating Principal in our college. Then the organizing secretariat includes Professor Inderkant K. Singh, then the coordinator of this event, Dr. Sandhya, where is she? Okay, Dr. Sandhya, then Shahjad, and other senior faculty, Dr. Varsha Baveja, then Manisha Sanger, and all my young colleague, young brigade of newly appointed, all my faculty members of Department of Zoology. There is a huge big list to avoid that time constraint. Then the entire Department of Zoology, non-teaching staff members, volunteers of Department of Zoology, and a great thank to our speaker, Professor Viranut from Thailand, then Dr. Roshan and Dr. Avasthi, who made this one-day symposium a grand success. I would like to thank the Almighty who made it possible. Otherwise, it was not possible at this short notice that we could organize this one-day international symposium. And last but not least, I would like to thank our principal who has contributed, who has supported financially to hold this one-day international symposium. और मैं चाहूँगा सबसे बड़ा धन्यवाद देने का जो हमारे स्टूडेंट्स हैं, पार्टिसिपेंट्स हैं, not from Deshbandhu College, from different part of who have joined online, अलग-अलग areas से join किया हुआ है, and then student from abroad as well, and some faculty, researcher, scientists who have joined from abroad. So I would like to thank all of them who made this one-day international symposium a grand success. And last में मैं चाहूँगा हमारे जो speaker रहे हैं, chief guest, उनका भी भाषण सुन करके मैं मंत्रमुग्ध हुआ हूँ, जिन्होंने किस तरह से हमारे यूथ को चैनलाइज किया है, डायरेक्ट किया है, दैट यू हैव लॉट ऑफ पोटेंशियल. यस, मैंने पहले भी जिक्र किया था कि बहुत साल हो गए, जैसे सर ने कहा डेवलपिंग. यस, देयर आर सर्टेन एरिया वी आर फार बेटर देन एनी डेवलप्ड नेशन, चाहे वो आपका मिशन मंगलयान हो या स्पेस रिसर्च की बात करें, हम मेडिकल सेक्टर की बात करें ना, आजकल आपने देखा होगा एवरी हॉस्पिटल इज फुल ऑफ इंटरनेशनल पेशेंट्स बिकॉज वी आर गिविंग द बेस्ट ट्रीटमेंट टू देम। चाहे वो हमारी फूड सिक्योरिटी की बात हो, बहुत सारी ऐसी चीज़ें हैं कि हम एक्सपोर्ट कर रहे हैं, वी आर सेल्फ रिलायंट इन मैनी एरियाज। और आप जैसे युवाओं के ऊपर अब निर्भर करता है कि जो चैलेंजेस हैं, जो थीम ऑनरेबल प्राइम मिनिस्टर ने हमें दिया है, जो हमें एक मिशन दिया है कि 2047 तक 2047 तक देश विकसित होगा, उसमें हम सब का अहम योगदान है। मोदी जी अकेले नहीं हैं, उनका सपना साकार करने में हम सब का कंट्रीब्यूशन, बराबर की भागीदारी होना बहुत जरूरी है। और जैसे सर ने कहा, मैं बहुत प्रेरित हुआ आपके अभिभाषण से सर, कि यस वी आर हेयर टू मेंटोर यू, यू कम विद द प्रपोजल एंड ट्राई टू सी देश की चैलेंजेस कहां हैं, कौन कौन से ऐसे ग्रे एरियाज हैं जहां पर हम सब मिल करके काम कर सकते हैं। लेट मी टेल यू, एक आइडिया पूरी जिंदगी बदल सकता है। वो आइडिया हो सकता है हमारे रिफ्ट चाइना से हो रहे हैं, आप कोई प्रपोजल लेकर के आ सकते हैं गलवान सिटी पर, क्या ऐसा हम कर सकते हैं जहां सॉल्यूशन आप दे सकते हैं। चाहे वो पाकिस्तान हो, हम कैसी स्ट्रेटजी फॉलो कर, पॉलिटिकल साइंस के बच्चे क्यों नहीं ऐसे प्रोजेक्ट बना करके लेकर के आते कि हम जहां मुंह तोड़ जवाब दे सकते हैं। या हमारे चैलेंजेस है, अपकमिंग चैलेंजेस है, चाहे वो पानी की समस्या है, एनवायरनमेंट की समस्या है, आप लोग उस पर विचार करें, विमर्श करें, क्लोज ग्रुप डिस्कशन करें, सॉल्यूशंस लेकर के आए। अभी यूनिवर्सिटी की तरफ से हम सभी को प्रपोजल सबमिट करना है। इतने सारे चैलेंजेस हैं, उन चैलेंजेस के क्या रेजोल्यूशन हो सकते हैं, क्या समाधान हो सकते हैं, वो राइटिंग में हम दे सकते हैं। देशबंधु कॉलेज ने उस चीज को इनिशिएट किया है। सो यू कैन गिव सर्टेन रेजोल्यूशन, सर्टेन सॉल्यूशन टू डिफरेंट चैलेंजेस। ठीक है, ये कड़ी उसी का हिस्सा है, विकसित भारत, स्वस्थ भारत। जैसे सर ने कहा, स्वस्थ भारत, विकसित भारत। हमारी परंपराएं बहुत गूढ़ हैं, हमारे पास बहुत नॉलेज है, ट्रेडिशनल नॉलेज बहुत सारी है। उस नॉलेज को कैसे यूज किया जाए, कैसे स्वस्थ रहा जाए, और कैसे अपने देश को 2047 तक विकसित बनाया जाए, आप सबका कंट्रीब्यूशन उसके लिए अहम है। मैं सब उन लोगों का धन्यवाद देता हूं जिन लोगों ने, हो सकता है मैं किसी का नाम भूल गया हूं, जिस किसी ने भी चाहे छोटे से छोटा, बड़े से बड़ा कंट्रीब्यूट किया है, मैं उन सब का तहे दिल से शुक्रिया अदा करता हूं। थैंक यू सो मच, धन्यवाद, नमस्कार।
Okay. So dear participants, kindly join us at cafeteria for a commemorative photograph, and kindly fill feedback form to get e-certificate. And all the participants who has joined through online, they have to fill the attendance sheet to get the e-certificate. Thank you.